It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Welcome everyone to another episode of Pure Performance. As you can see, well, you cannot see because it's a podcast, but as you can hear, this is not the awesome voice of Brian Wilson. You got to deal with me today only. This is Andy Grabner. Our host, Brian, unfortunately had some stuff that came up. We talk about AI today and vibe coding. Unfortunately, Brian couldn't vibe code himself out of the situation to make it in time. But Brian, I know this topic is most likely something we'll have come up more often now in our future episodes. So I'm pretty sure you will have a chance to discuss this topic. But now I want to introduce my guest. My guest is Abhi for short. I don't dare to pronounce the full name, but Abhi, before I let you give us a little bit of background about yourself, we met each other at Cloud Native Days Austria. There was a conference here where you were presenting, and I'm reading out loud, Beyond Reactive Systems, Event-Driven Architectures for AI Agents. I had the pleasure of welcoming you on stage because I was moderating that conference, and I thought this is a really cool topic and talk, and I want to just get you on the podcast. Now, Abhi, over to you. Please let us know who you are, what is your background, and what brought you into building that event-driven app with AI agents. What does vibe coding mean to you? There will be some things that I want to kick off this conversation.
All right. Hey everybody. Thank you, Andy, for having me in this podcast. And Brian, virtual hi here. We'll surely catch up after this. I'm Abhi. My name is Abhimanyu Selvan, but you can call me Abhi. I have a background in embedded systems and robotics. I did my bachelor's in electronics and communication, and then I moved to the Netherlands 15 years ago almost, where I did my master's in embedded systems and began my career as a software engineer, programming cockpit display systems for aircrafts, Boeing, and Airbus A320s and Boeing 787s, and then eventually moved into autonomous or automated robots. Autonomous is an overkill. Automated robots that are running in industries like Porsche, Mercedes-Benz, who worked in a couple of German automotive clients. Eventually got myself my hands dirty in the cloud native world with Kubernetes, moved more into cloud infrastructure and DevOps, and became the head of software engineering for a medical IoT startup, working with patients with sleep apnea and helping them, sleep better. And then I joined a 4-person Kubernetes startup in the Netherlands, which later got acquired by Akamai. And I joined there as a developer advocate. But as a developer advocate in a 4-person company, you can do a lot more than advocacy. That was really nice. Eventually found my way into DigitalOcean cloud infrastructure provider, where I started as a Kubernetes advocate, and eventually I ended up heading the developer advocacy team at DigitalOcean. Last month, I made the decision to resign from my role, and I started pursuing some independent projects that I was interested in, and also taking a step back to understand more about AI systems and what that's pretty much my background. And I had the pleasure of speaking about a project that I was building. And the whole reason for that is, the whole buzz, the AI buzz kick-started 2 years ago. But the beginning of this year, when I looked at it, I didn't have a background in AI ML, but I had a cloud infrastructure background. So I was like, how do I, use these LLMs and how can I use my background, my skill sets to adopt these tools and technologies and build something cool. And as a result of that, I went through this whole exercise of working and with different coding agents and cursors of the world, GitHub Copilots. And as a developer advocate, right, you needed to do two things. One, you wanted to inspire people on what is plausible on our platform, and two is to enable them with the right set of tools and SDKs and content. So when I started this project, I was working at DigitalOcean, and we're a cloud infrastructure provider. So I was like, how can I build a really complex or an advanced project that can resemble with some real life scenario, but at the same time will act as a framework to showcase how these AI agents can talk to one another at scale. So the question that I was trying to answer, ask myself is, yes, there are these AI systems, but what would the infrastructure look like when these multiple AI systems are deployed at scale? How will they communicate with one another? How would that look like? And this question kind of like drove me into the project that I presented, which was like a ride share platform, a clone of Uber. That my goal was to have that platform and, as a framework where I can validate my idea, whether this idea is right or wrong, whether event-driven architectures is going to power these AI agents communication. So that's the long story short, but I'm sure we're going to go into detail about how we built that. But that's how I ended up, building this clone of Uber. I vibe coded it, or should I say vibe engineered it?
Vibe engineered, yeah. I mean, I got so many questions now. But first of all, folks, if you want to see Abhi's talk, then, we always put the links into our podcast description. The talk that you gave at Cloud Native Vienna is on YouTube. So it's called Beyond Reactive Systems, Event-Driven Architectures for AI Agents. In hindsight, I'm actually wondering if the talk you should have probably called it like maybe vibe engineering, right? Vibe engineering, how I vibe architecting maybe, right? How I vibe architected an event-driven system.
That's pretty much, I gave this talk at like 2-3 places, but as and when I was giving this talk, I felt like this is much more of value to people, particularly in this era where, you're adopting tools like cursors of the world. And that was that's a good feedback. And that's something that I'm definitely should have considered now that you think about it in hindsight, right?
Yeah. And, we talked about this earlier. While Cloud Native Austria 2025 is over, Cloud Native Austria 2026 is coming, and we just opened up the CFPs. Oh, yeah, we got the beanie. Yeah, awesome.
Stay Cloud Native. It's a pity we can't show it, but I have it.
So what I'm interested in now, obviously, there's a lot of stuff that is happening in the cloud natives, but in the AI space, right? You said you started vibe coding earlier this year, so early 2025. And this feels like almost an eternity if you think about the advancements that all of the models and the AI agents have come. Did you feel this as well while you were going through the project, that maybe with every week or with every month, things got just better? Or did you get better in using the system? So is it a combination? How can you kind of quantify that a little bit?
Yeah, it's an excellent question, actually. And I think it's a very valid and pertinent question in today's software development. So when I picked up Cursor was like when Cursor launched, like mid last year, when it was getting traction. We experimented as developer advocates, right? What are the new tools that are out there? And we were one of our team at DigitalOcean was one of the first teams to try out Cursor. And we were like first just mind blown by the initial, the ooh, wow, I could just ask this and, get something up and running. And we advocated for it within the company. But as an organization, the engineering teams were already using, for example, GitHub Copilot. And we did use GitHub Copilot, and I at that time when I used it, I don't know how good it's become right now. At that time when I used it, it was not that great. GitHub Copilot was not giving me the right code, and it was not able to understand the right context, whereas Cursor was able to understand all the directories that I had in my workspace and produce much better result. And it was the whole experience was really nice. It was like just a fork of VS Code, right? I could just import all my existing plugins, and the seamless integration was really nice. So we started that whole thing. And of course, every single, and we had all these new tools coming up as well, as and when we were building Cloud Code. My one thing I was very clear is I wanted to stick to one tool. I wanted to commit to one tool and go deep into that one tool, because you're oftentimes, you have Warp, you have Cloud Code, you have so many new tools, Kilo Code and all this. I didn't want to deviate and distract myself into trying out multiple different things, because Cursor was already giving me what I wanted. So I just picked one tool, and that's something that I also recommend people as one of my learnings is instead of getting fascinated by all the new tools coming out, just pick one tool and commit to it. If you're more of a Vim person, maybe Terminal is your user interface is your thing, maybe Cloud Code is a better. Eventually, I think all these tools are going to produce like similar results, and all these models are going to hit a plateau where everything, it's just a matter of preference at a certain point, right? Like we've hit a point where I think it's pretty much that, and a tool is only as good as its user, right? So if the more you can extract out of these tools is the better. It's not because you give someone Cloud Code, they can super code someone, outdo someone with Cursor, but if it depends on how good you want to use the tool and how can you extract more out of it. So I think it's a combination of committing to one tool, but also trying to go deeper and trying to learn how these tools operate. But yeah, if you want a certain example, right? And it was funny because when I started, I just gave build me a clone of Uber. I just gave a single prompt and I said and it threw a bunch of scripts. It didn't work, but the whole, what I got out of it is it gave me some ideas about event-driven design and how I can build this system, right? If you think about it, these AI agents are pretty much like humans. They have to operate independently, asynchronously. They don't have to wait for. So let's say that I needed some input from you and you're working on a project, but maybe it's taking you some time. So I'm not going to sit and wait there till you give me that. I'm going to do my other stuff, and when you come, I'm going to pay. I think we have to think agents pretty much like humans, and I think event-driven design, and I believe event-driven design. Let's forget about the tools or the Kafka or message queue, what it is, the technology stack, but more of the design in itself, event-driven, is going to power these AI systems at scale. So so it gave me that thing, and I went deep down into trying to understand if people have done it, and there are some people at Confluent who have been advocating event-driven design, like Sean Falconer and a couple of folks in the industry. So I've been reading their blogs and their tutorials and trying out their projects. So I took a lot of inspiration from that, and said, how can I apply that to my coding experience? So that's kind of how I started.
Yeah. So that means you were, just to recap, you started with a very blunt prompt, build me an Uber-like clone, right? Obviously it didn't work, gave you some ideas though on if you want to build something like this, you need to think about the architecture because it's a complex system. They brought you to what event-driven architectures, and then you did your own research on that particular topic. Did you then go back with all of your lessons learned and you gained knowledge about that topic and went back to the AI agent and then said, hey, basically rephrasing your prompt, obviously, right, with all of your knowledge? Yeah, that's how it worked?
100%. That was just I wanted to see what it's going to do. It's not I wanted to take that path of just build me a clone and I'm going to work on it. I just wanted to see how far it's going to go. And maybe the same prompt nowadays can maybe build a better version of what it did 1 year ago. but it was just like a fun exercise that I did. I didn't take any code from that version at all. The only thing that I took from it is the inspiration that it gave for event-driven design, and it suggested a tool like Mapbox. So Mapbox is an external map service where I can basically load a map and perform some roads and things like that. So I did not know about it. So those two are the fundamental things that are still there, but the code is not there. So what I did next is I took a pen and paper, and this might sound, I don't know, pretty old school. But I also have my notes I can probably share you. Like I literally took pen and paper and I started writing out like what I want this system to look like. What is the business logic flow basically? So when you're building, I wanted to think like from a customer and a business standpoint rather than an engineer, right? So in this case, usually engineers were stuck with like a tech stack and I want to optimize the code, but I want to move all that. If I want to launch a product, what would that be? And I decided that, yes, I'm going to do a clone of Uber, but I did not know anything about it, right? So I started writing the business logic. What are the components that we need? We need someone like a rider, someone requesting a ride. You need some sort of an interface where these requests are accepted. You need some sort of a centralized system that processes these requests, is also aware of where the taxis are. So you need like some sort of a taxi simulator. So I started like drawing out these. And if you see my talk, I also have like a flow diagram there in the talk where I talk about it. So is this when you're listening to it, if it sounds more abstract, but maybe you can also counter reference it with the talk where I have the slides. So I started drawing this business logic flow, and if you think about it, these event-driven design should actually empower your business logic flow. So a request is an event, something processing is an event, a billing agent is something taking that ride information and calculating a city-based prices is an event. So everything started flowing as events. So I started like drawing out these events, and then once I had this in my paper, and then I started drawing them out as in my canvas in certain tools, and I had them as like my images, architecture diagrams. I had that first as one of the contexts that I wanted to give cursor. The second one I wanted to do is I started determining the data structure. What would the payload look like? What are we talking about? Like, what does a ride request mean? Right? It should what information should it have? A ride ID, a user ID, the pickup location, lat long, drop off location. So I started for each of these components. I started writing down the payload, like what does the struct look like? Basically, a JSON for the Kafka topics, which will come later. Writing them down and then drawing the sequence diagram. So I had three more inputs, right? I had a high-level business logic flow. I had the data structures and the payload of what a ride would look like, what would for each of these events for different components. And then I had the sequence diagram written as an MMD file. So basically, with all this information that I did, I used Cursor to generate the MMD file. Once you have all the sequence ready, I gave it to Cursor and it gave me the MMD file, and I converted the MMD file into an image. So I had all this information now. And then what I did, I gave it to Cursor. Listen, this is all that I have right now, and this is far more context, right? It has much more context, and I gave it. And that was like my first kind of like my serious iteration, if you call it. Like I gave this to Cursor, and it came up with like a much better. At the time, I think I was using Claude Sonnet 3.5 model when I first tested it out. And it gave me a lot of Python scripts, and it understood it better, and it automatically started designing Kafka topics for it. And it gave me I was pretty impressed with how far it could give. But it didn't work. It gave the code, but when it gave me the startup scripts and everything, but when I ran everything, it didn't work. And then I realized a huge lesson back then was context is very important, but I think these AI systems or these AI agents work far better when you give them micro increments. So you have macro context and micro increments. So that was kind of like my second learning was context is important, but you don't give the context all at once. And you kind of like, break it down into planning and tasks. And now Cursor and all these tools have this mode called plan mode and task mode, where you can have like checklist of each of these. How do you want it? But when I started it, it was not available. So, but this was like a self-learned lesson back then when I broke them down into different like micro tasks. And then I said, okay, do this task. After you complete it, we do a test, we verify it, and only then we move to the second one. And that took me a lot further in the process of building this. So that was like my first serious iteration.
Yeah. So if I recap, fascinating. Thank you for those answers. For me, what I take away from this, it feels a little bit like being good in writing good product requirement documents. Because you said, right, just saying I want an Uber clone, that's not enough. So you need to really figure out what is the problem we really want to solve. What are the components involved? What are the flows? And I think if you are a product owner or a product manager, or you're designing a product, you need to get very good in describing really what is the problem you want to solve for whom, and how should that particular, consumer then in the end really walk through your software system to get this stuff done. And then I think the other thing is with like breaking things down into smaller increments. That's essentially the same thing in how we do software engineering, right? We always break things down into smaller pieces. Now the benefit, however, and correct me if I'm wrong, and I think this is what I hear out there, the benefit of now having these AI systems, if I'm non-technical, but I know what problem I want to solve, I can use these systems now to get fast iterative feedback, because I don't need to wait on a software engineer that may have time next week or next month. I don't need to pay somebody to get this done and give me feedback and then try it out, but I have very rapid feedback loops to validate if what I try to build actually feels good, not only for me, but I can also give the prototype to somebody and then get rapid feedback, right? I mean, I
think it's 100% true. I think it's good that you mentioned about product managers. I think the whole product manager category is going to be like, it's now slowly changing into product engineers. So basically you need to start thinking more from how the PRD is, but also rapidly prototype. Instead of having like a wireframe and things, you can rapidly prototype something and give it to early. And let's say you want to build a feature and you have a team of engineers. And as a product manager back, like, I don't know, a couple of months back, people would like write, and even like in a couple of years ago as well, like until a couple of months ago, people are writing like specs and Jira tickets and breaking down into tasks and epics and all that. But now with all these tools that you have, I can do I can still have my PRD and my spec written down, but also have a short proof of concept ready and attached to it. And I said, okay, this is exactly what I want, or this is something that I want. And the engineers can then take that as inspiration and work and make it more robust and production ready. But this will rapidly also reduce like the time it takes for engineers to build, but also rapidly launch new features. And with lean and mean team, I think with like less people, you'll be able to go further. And this is what is like, as you clearly mentioned, like it's redefining how you're going to do software development. And they have now these frameworks called OpenSpec and things like that, where from Cursor itself, you can say /spec template with this Jira issue, create something. And so we're redefining the whole developer workflow.
Yeah. I'm a big fan of analogies. And one of the analogies I may want to bring, because 2 years ago, my wife and I, we moved into a new apartment, or we had the chance to, it was a house that was under construction, and we bought the apartment that was not yet built. So we had a little bit of a chance to architect it, right? And the beauty of it was, we worked with somebody and he started to build a 3D model of, how our place will look like. And we had a chance to walk through that apartment, right, in 3D and actually see, actually this doesn't make sense. This doesn't feel good. This feels good. Color looks strange. So it feels the same way, right? The person that did the 3D rendering and the designing had a chance to do rapid prototyping with us to validate it before they actually then gave it to the real builders to say, now you're going to build this, but we know this is going to be good because they have told us that this is what they like because they've seen it in a prototype 3D model.
Yeah.
So it's the same thing.
I mean, that's the whole power. Like when they say like AI is going to replace people, it's like AI probably will replace people who are not using AI and people who are like able to use AI to provide more value. So then now this designer that you and your wife met is showing you more value, and he's taking you, or she, whoever it is taking you through that journey of you experiencing it, how and with all these modern tools. And this is why I think I'm bullish in the sense that I'm not against it. I think we should embrace AI and of course validate it, verify it. That's a different problem. But I think you need to embrace it so that it definitely is a production. A boost.
A boost,
for sure.
Yeah, it's efficiency boost. It shortens feedback cycles. It allows us to experiment more as well, right? It allows us to go into multiple different directions at once or validate and then come back with the right path forward. And we have, I always say, we can make better informed decisions to move forward because we have more valuable feedback from different attempts to try something right now because we can move faster.
And now they launched all this background agents. So one of this is, and particularly let's say something that I learned was I had like 10 microservices, right? So in my architecture, I split it into like a couple of microservices, and it didn't do a good job then. So I containerized one service, and then I gave it as an example, say this is how I want to containerize it, and then it did a far better job of containerizing all this, and giving it a Docker Compose example, and then it was able to do it. But when I just said like, okay, now turn these Python services or into a Docker container, and it didn't do a good job. And this was needed because I wanted to validate each and every service, right? Like instead of scripts, I wanted to have these modular services that I could stress test. And so this is how what I'm saying is like you need to work with it like hand in hand and try to teach it, and you learn from it. And it's sort of like your buddy. Truly, I think it's like your programming buddy here that you can brainstorm and rapidly build something together.
And I also think you mentioned now they're building these background agents or whatever you want to call them, right? Basically agents that are kind of listening in and kind of trying to and see what you do, but then only show up when they have something to say, right? And if they want to contribute. So this could, for instance, be if there would be an architecture agent that is sitting in the background and it sees what's happening in your code base as you're working with your coding buddy, then at some point the architecture agent could come up and say, hey, I wouldn't do it like that because this is a bad practice, right? You're not thinking about resiliency. You're not thinking about failing over. There might be a better pattern for this particular thing, right? You should hide this behind a feature flag and things like that, yeah?
No, it's an excellent point that you bring. I think this is something that even yesterday I was at an event in Utrecht when I was talking about it. Someone suggested, why don't I have one agent per service attached to it? So when you have these agents.md files, right, like you gives the rules of how you want to build. So let's say you have a Rust backend and you have a couple of Python services. So you just define how you want each of these services to do in these rules, and you give it to it. And as you clearly said, you have like one master orchestrator agent or the super agent in the background that kind of has the overall context. And then you have micro context for each of these services. And I think maybe it's something that I want to try now is with this whole architecture. I've just done it with one agent. I'm going to now like split every service and have an agent for each of these services. And when you mentioned about the infrastructure, the super agent, I'm going to have a super agent as well. And I'm going to see how that's going to work, because I learned it the hard way. Like you try and build something, but when you stress test it and you validate it, and without having proper observability in place, I ended up losing a lot of money as well, which is something that in retrospect, I went back and I then started instrumenting instrumentation to a couple of these services. But yeah, I think that's a very good point, and that's something that I'm going to take from this talk for sure, is to try this out, this approach.
Yeah, because if you think about it, coming back to the house analogy, you could have a general contractor, right, that is basically taking care of the whole end-to-end project. They have the oversight. Then you have a company that is responsible for building the structure. You have a company that is responsible for the electricity, for the plumbing, for the interior. So it's the same thing, right? In software engineering, if you do it for the individual services, then you may have an agent that knows and is trained because you prompted it what this should be, right? What should that service do, and how should it act under load, and what is the service it provides? And then you can have agents that are really then. Now, at the end, the question in the end is, do we use agents to build these systems, or will the agents in the end become the service? Do we just in the end no longer build any type of microservices or systems anymore? Right? We just build agents.
On the fly.
Yeah, no, we just build agents, and every agent then gets triggered through events, and because in the end the agent is then doing its job, right? So we'll see where this goes. It's really fascinating. Yeah.
Indeed, it's really fascinating, and but I mean, for the listeners and people who want to experiment with it, I would just say that go through a process of building something. I think that's the only way that you can learn. Reading about it, watching YouTube videos, and trying out some simple projects will, it might be just like. But if you want to truly experience the power of these software tools, I think now is like the time. Like back then, when I had an idea, I was not a front end person. So to even think of building an app like this was not even. So now you can also play to your strength, right? So if you're really good at back end, maybe you can allocate all your like a couple of your agents to build the front end for you and focus on the back end and work together. But yeah, unless you go through this process, you'll learn a lot, and I think and you'll be inspired, I think, to build out.
Yeah. I have one more concept that I want to quickly kind of bounce off of you, because I'm co-authoring another book after we wrote Platform Engineering for Architects a year and a half ago with two other authors from the CNCF space. One of the authors, Hillary, she asked me to do another book with her, and then this one is about AI ops, kind of like the modern observability in the age of cloud native and AI native. And one of the chapters I'm writing on is actually trying to figure out what does agentic AI really mean in context of observability. And you brought observability up in what you said earlier. And so I'm actually talking about, I bring some examples on, I'm in, let's say, in Cursor, or I'm in Visual Studio Code, and I'm using GitHub Copilot and say, where do I need to optimize my code to be faster, to be more performant? And then Copilot could reach out to the backend observability system through an MCP agent and then make some suggestions. And now my point that I make in this chapter is, if I just use a general trained model that doesn't have any experience in performance engineering, in site reliability engineering, of course I will get benefit out of it, but it's like working with an apprentice. An apprentice is somebody that has a basic understanding of the world, but is not an expert yet in that particular domain. And then I talk about how we can elevate that apprentice to master, right? Because in the end, you want to have a master agent. Mastering meaning knowing the trade of this particular area. And I can do this by, training that model on what does it actually mean to build a resilient and performant app. So you can do this through instruction files. You could obviously build your own agent that is then, using your own trained model. But I wanted to see if kind of this idea of from apprentice to master, mastering a trade, is this something that you have experienced? The more you worked with Cursor, the more you work with it, the better it got, because the more context, the more it also learned from you?
Yeah, for sure. What initially, like when you're getting, you're just, it's a two-way thing, right? Like it's It's like trying to work with like someone who's joined the team recently, and you want to work closely, pair program together. You're trying to understand what you want to say, and then they want to. So earlier, maybe my prompts were not good enough. The way I provided context, my context engineering skills was not good enough in the beginning. But also at the same time, I think the model was not. So it's like working hand in hand, and as and when the model was also getting better, and like I said, like from the beginning of the year, I've been fully working on this. So it got better, and right now with I think like Cursor launched one of their own models, like Composer model, and I think that's I've not gone into details of how they've implemented it, but when I compare that with the results that Claude is giving me, I find Composer model from Cursor gives me code that is much more relevant to my project, much more impactful for my project, and with less errors. Then so I think that it's a two-way thing. When I also try to learn better of how I need to provide context, but also these specialized models, coding models are getting better, which is why in Cursor, if you hit a limit and you switch the mode to auto or some of these low models, it just creates a mess. So what I started doing is I have like 3 tabs now. So any questions that I want to ask or planning or something like that, I use like a lower model. But when I move into the agentic mode, I make sure that it's in the compose model, so that I don't use like waste my tokens on like Composer to ask basic questions for it. So yeah.
Cool. That's an awesome suggestion, right? Because obviously, you can still probably also find some information just by old Googling, right? It feels strange to say, are you still Googling for data? But yeah, exactly, right? But so this is the cheapest option, and you also get it. But then you always have to weigh, what you want to get out, how fast you want to get it, how impactful should it be, and then you can use different models that are charged differently.
Yeah.
Well, hey, Abhi, really, really cool. I know folks will obviously have a chance to watch your the recording of Cloud Native Austria. You just mentioned that you're speaking at different events, right? I guess
and like yesterday or 2 days before was my last event for this year.
For this year, yeah. Cool. No, it's fantastic. Maybe just a little bit of to wrap this up, a little bit of an outlook. Where is your journey going? What's happening next year?
Yeah, so basically, what happened was when I built this whole Uber clone, I started giving it to the hands of people, and it's all simulated, right? It's not like a real taxi is going to show up at your doorstep or something, but it's the whole idea to validate this distributed systems and how you're going to do it. As and when I got also like a lot of good feedback from the folks at Cloud Native Days Austria, one of like a very good crowd, highly intelligent crowd, and then also critiquing me of my certain choices that I made, like Kafka and things like that. But it was not like Kafka was not like deliberate. It was intentional, because I also wanted to promote one of our product offerings, Kafka, and as part of my talk, it was not like so it was a bit strategical move as well. So I gave it to hands of people, and then how they started using it was a couple of them started using it to explore their neighborhoods and the geography through taxis. And so they'll say, "Oh, pick me up from here, drop me off there." And some of the parents had kids, and they were like, Sunday I got a message on WhatsApp saying, "Hey, why is your app not working? Because my son wants to go to the beach and he's waiting for his taxi, doesn't show up." And that got me thinking. I'm like, wow, okay, there is a different angle to this application. I'm building a clone of Uber, and competing with Uber is never going to, like, it's far more complex, and it has like a lot of logistic issues, and it's, as a solo developer, it's going to take me a lot of time. So then what I thought of doing is taking all the learnings that I did from building this, and right now I'm focused on building a game. So it's going to be hardbyte.io. It's there in my slides, and my aim is to launch it a basic version end of January, early Feb. It's going to be in Android, Apple, and it's going to be also web app, where it's going to be still maps and exploring your neighborhoods, but it's going to be in a far more fun way. And then you're going to have a lot more agents in the background working together to give you that experience. So that is where I'm moving forward. I'm not going to spend more time on this particular RoboTaxi platform, but I'm taking that and building a game so that anyone across the globe can play. So yeah.
Awesome. I will definitely try it out for Linz, Austria.
For sure.
So to explore my neighborhood. Yeah.
Yeah, for sure.
Yeah. And maybe this is the this is then I think we talked about this in the preparation. This could be your next talk for Cloud Native Austria, because
Cloud Native Austria.
Yeah.
I still need to figure out what's the story that I want to say there, but definitely, I've selected. It'll be a live demo, and everybody in the audience can start playing the game, and that will be like a really interactive session. But that's where I'm heading.
Yeah.
Of course, I'm also working on other side projects and helping other companies where I can with my skill set. But my focus now is to get this game up and running.
Yeah, cool. Well, that's awesome. All the best for this, and keep us posted. Definitely looking forward to this. Also, thank you so much for this discussion. It's always great to hear from somebody that really had a longer experience. So I really like what you said in the beginning. You said commit to a tool in the beginning. I think that was a really nice thing to say. Also, the way you started with kind of like a very vast prompt, like create an Uber clone, and then how you then refined. You really had to think about what do you really want, because this is most often the toughest thing, especially for very technical people, right? Because we always like to solve technical puzzles and problems, but we don't really think about how to eloquently describe on what is the real problem we want to solve, because the solution, how to solve it, should be secondary. First is really like, what's the problem we really want to solve, and then figure this out. Yeah.
I think these tools are just making us become clear thinkers. So if you're a clear thinker and you exactly know what you want, these tools are mainly executing it for us, and that's it.
Yeah. Be a clear thinker. Yeah. Awesome. Hey, Abhi, again, thank you so much. Folks, if you listen to this and you want to follow up with Abhi, the link to your LinkedIn is there. Also to the presentation that you gave in Cloud Native Days Austria, and we will make sure that anything else we discussed today will make it to the links section of the podcast. And to Brian, sorry that you couldn't be here. Hopefully everything is good. We'll see you in the next recording. And Abhi, I hope I see you next year.
Thank you, Andy. It'll be a pleasure. Definitely we'll meet up.
Thank you.